Hello everyone, and welcome to this session. In this video, we're going to talk about ABI. What is it, what's its benefits, and why use it in our Algorand applications. Usually, when creating a smart contract, you will define different methods depending on your business logic. And of course, some clients like wallets, mobile apps, or any other frontend will try to call these methods inside your smart contract. And there comes the first big questions. How do these clients know the correct way to call these methods? Which arguments send and what to expect? Also, remember that the Algorand virtual machine only supports two data types, byte arrays and unsigned integers. And when creating your business logic, you may want to use other data types, such as booleans, strings, etc. And there's the second big question. How to use these data types? And the answer is ABI. ABI stands for Application Binary Interface. It's a standard that defines how to encode, decode data, and how to expose and invoke methods. This enables a standardized interoperability between smart contracts and application. ABI was introduced with Arc 4. You can find a link to the complete Arc documentation in the description of this video. Thanks to ABI, any clients know how to communicate with your smart contract without reading the whole code, and you are able to use other data types besides byte arrays and uint, making easier coding smart contracts in Algorand. And one of the main components of ABI is the JSON artifact. This artifact, usually named as contract.json, describes the whole smart contracts at a glance. As we can see here, just by reading the JSON file is enough to know that we have a smart contract called calculator that has a method called add, which receives two arguments, A and B, both of type uint64, and this method will return a uint64 value. Did you see? That's the magic of ABI, and any client will be able to read this and understand how to interact with your smart contract in Algorand. Let's demonstrate this using Dappflow. In this scenario, Dappflow will be the client who reads the JSON artifacts. Let's go to ABI Studio, import ABI, file, upload file, and let's select our contract.json that we just showed in the last minute. And now, Dappflow knows that this smart contract is called calculator that has one method called add, which expects two arguments. Let's see here. Expect the argument A and B, both of type uint64, and we return a uint64 value. Also, we can see here the method signature and the method selector. We'll see what is this in the next slide. All this info Dappflow knows just by reading the JSON artifacts we uploaded. That's the magic of ABI. Now that we know what's inside this ABI JSON artifact, it's easy to understand his role in the whole application. Every client will read this artifact, understand how the smart contract and method works, and will be able to build a correct application call to interact with the desired method. But how the client will indicate to the smart contract which method is trying to call and how the smart contract will understand that application call? Signature and selector are the answer. The signature is the unique identifier for each method. It's generated by a concatenation of the method name, parentheses, the data type of each argument, parentheses, plus the data type of the return value. Here you can see the signature for the method that we saw in the ABI JSON artifact. Once you have the signature as the identifier, the application will need the selector, which is the hash needed to identify the method, based on the signature. To get the selector, we just hash the signature using SHA-256-512 and then get the first 4 bytes from the result hash. In our add method example, we get FE6BDF69 as selector, and this is what goes inside the application call as an argument. This is what the smart contract will use to identify which method your client is trying to invoke. As you can see here, in this teal example, we're comparing the selector inside of the application argument position 0 with the byte array 0xFE6BDF69, which is the selector corresponding to our add method. So, if the application call contains this selector as an argument, the smart contract will execute our add method. But don't worry, all the hashing and signature selector generation is handled on the client side by the SDK and the Atomic Transaction Composer, so you don't have to worry on building it manually. Now let's see how ABI helps us to have different data types in our smart contract. Remember, the AVM only supports byte arrays and unsigned integers. Thanks to Arc4, ABI introduces new ABI data types. Each of these will be encoded to its corresponding AVM data type when interacting with the smart contract, and will be decoded as well. And all this decoding and encoding will be handled by the SDK and Python, so you don't have to do it manually. All this allows developers like you and me to code our Algorand smart contract in a more familiar and easier way, using the known data types we love. Thanks, Algorand. This ABI data types is the reason why you will see things like this in a high-level language perspective, using Beaker, Python, or just Python. Inside the parentheses, you will find pt.abi.uin64. That means that the method is expecting an ABI uin64 value. Also, below you will see a a.get. All of this is needed for encoding and decoding purposes, so Python can handle. Here you can see all the data types that ABI enables for using in the Algorand smart contracts. Probably you're familiar with all of them. If you want to dive into the ABI data types, I'll put a link in the description that will take you to our developer portal with this chart and more information. Lastly, the ABI also specifies the special types and how to use them. In Algorand, we can work in a method and transaction with data from different objects, including other transactions. And the ABI has it covered with the special types. These ABI special types include the foreign or reference types for using accounts, assets, and applications inside a method and an application call, and also the types related to transaction types. Let's see an example of how are these special types involved in the ABI process. For a signature like this, you can see that we are doing a call including a payment transaction, 2 arguments of type uin64 and an account, and we'll expect a uin64 value as a return. This means that we are sending one payment transaction along with our normal application call. Any other client that reads the ABI JSON artifact or the signature will understand this structure and will need to fulfill the requirements for this calling. They will need 2 transactions in a group with the described argument. Let's see an example with some numbers. We'll need to send as arguments our selector and 2 uin64 values. And we'll need to send 2 accounts, the sender account, as always needed, and the required account argument. And we'll need to create a transaction group with a payment transaction and an application call, just like the signature indicates. The JSON artifact for this method that we see will look like this, indicating the pay type and the account type as the first and the third arguments. Now let's use Dappflow again to demonstrate this. I have already uploaded the JSON artifact. As you can see here, Dappflow knows that this method needs a pay transaction and an account as an argument. We can see the variable A is a pay type, a payment transaction, and the variable D is an account argument. Let's click execute. And Dappflow will request the required arguments and to create a payment transaction, just as we specify. Again, all of this is thanks to the ABI artifact we provided that Dappflow reads and understands. And that's how special types and all ABI works, making our life easier and more familiar when creating smart contracts in the Algorand blockchain.